Welcome everyone, Rabid here. Today we are looking at the 5700 XT, the Nitro version for that matter. Ethereum fees are down, so we're going to check out Ravencoin, some efficiency settings, and hash rates. Our system is on. We are running no card, with our consumption sitting around 19.2, 0.8. I guess we'll just ground it out at 19.5 for the middle right there. So now that we do have our power draw from our system, we can take a look at our card and install it. But first, I just pulled my 584 gigabyte card off there, and that thing is still pulling 26.9 mega hash on Ethereum. If you haven't seen that video, you got to check it out. But yeah, so here we have our Nitro from Sapphire. This is the top-notch card for AMD. If you buy AMD cards, if you have a choice, always go for the Pulse or Nitro, and Nitro being the top of the line of Sapphire. It does have a 3 BIOS switch. If you guys can kind of see that right there. So right now we're in the middle, which is performance. Actually, no, this is silent because we are modded to non-XT for better Ethereum watts per what do you call it, power consumption, I suppose. We're going to check that out in a later video with some reference changes, see if that still is true. So all the way to the right, so that's all the way that way towards the front of the card. I call the front the opposite side of your ports. I call the ports the back, so your ports are here. So all the way to the right, that is for setting for, say, your software and everything in Windows, their trick software. Middle is silent, which I have the non-XT BIOS in there for ETH. And then the front, which we're going to use for Raven here, is our actual performance mode, which is towards your ports here. So we are in the front right now, so we're good to go. Once we get some settings figured out and efficiency, we will try the ETH BIOS bod to see if it makes a difference or not. So stay tuned for that. Let's get this card installed and see what we come up with. Our card is looking good. We are installed there. I am using 8-pin to dual 8-pin here. Nice thick braided cables. You can find these at nerdgears.com. If you use coupon code Rabid Mining, you will get 2% off your total order. So that's what I'm using here, an 8-pin to a dual 8-pin splitter. Going into the dual 8-pin on the top of the Sapphire here. Now, we are locked in. Depending on how the results are when we find in a nice efficient setting, I am going to put this on a riser and see if that makes a difference, just like we did with our 5600 XT test. And we did notice a small hash rate drop. So we're just going to check this out with the 5700 XT as well. So let's power this up and see what happens. Just wanted to point out the LEDs on this card look pretty amazing there. We can see if we get zoomed in a bit, it is upside down because of the way it's positioned. So yeah, Nitro, we got some nice RGB lights running across the top and on the back. So yeah, this is a nice looking card, and that is the Sapphire Nitro Plus. Here we are, Hive OS, and now we're just going to run in like we did with our previous two cards. If you have not seen our Raven test with our 580 and our 5600 XT, be sure to check them out. But we have not mined Raven on this card before, so we're going into the presets in Hive OS, and this is what they're suggesting for us. So we're just going to start with this as a base. With our 5600 XT, this actually turned out to be the best setting to use. So I'm just going to add the apply here. We're going to add those in. I'll probably have to do some mem tweaks and whatnot in a little bit, but we're just going to start with the quick default here and see what kind of hash rate and power efficiency we can come up with. While I wait for that to spool up, I went to what to mine. One 5700 XT on Kapow is estimating about 21 mega hash at 160 watts. So we're going to try to shoot for close to the same numbers, but make it better. So it looks like we are at about 20.8 mega hash. Let's take a look inside our miner. 20.81, 20.81, just updated 20.81. So 20.81 looks like our mega hash at these settings. So yeah, let's take a look at our power draw and see what's going on here. What are we at? Get some light in there. 197, 198. Let it even out here a little bit. Looks like pretty 197 point. We'll go 190. So a little spike there that happens. So yeah, 197.8 looks like a nice sweet spot, I'd suppose. So I was just writing down our 20.81 mega hash, and it actually shot up to 23.55. Let's see if anything changed on our power. So 23.55, and we're still sitting around the 198, probably down to 190. It took more stable 198 now, so we will probably have to roll with 198.5 now. 198.5 looks pretty 0.8, I guess. 198.8. Oh, geez. 200 now. Okay, come on. Even out. Gotta get some nice numbers here. Alright, we're going with 199. So to just be safe, I let this sit for like 10 minutes. And it looks like we're at 24.8 now. And it looks like 199 watts is still our number. 199.4. So yeah, we're still gonna go with 199. Except now we are at 24.07 mega hash now. So yeah, these are what we're going for these settings. So I tried the exact same settings here, our 1250 and our 910 mem, but I dropped our core voltage down from 810 to 720. We're sitting at about 23.67. Let's take a look at how much power, if it drops some power or whatnot. Obviously it should. So we're sitting at 182.5. 186, so we did lose some power here. So we're just going to do some calculations. 181 point that. So 182 is what we're going to go with here. So for our numbers, we're going with 23.67. We're going to look here. As you know, Kapow does fluctuate, so you'll never have the same hash rate constantly all the time. It does go up and down. That's just the way the algorithm works, so it keeps ASIC resistant. So with our first settings here, as you can see, we had 24.08 at 199 watts. That comes out to, after the system, 179.4 watt, 0.5 watts, which is 0.134 mega hash per watt. And with our new settings, all we did here was drop it down to 720 from 810. And we are using 162.5 watts when we take the system away, which gives us 0.145 mega hash per watt. So we're doing a little better here, so let's try some other settings and see what we can come up with. Okay guys, I have a big, I got some important stuff to say here before we go into this. So we're at 27.49 now. It was 27.5. I saw on Reddit some settings. Some guy he said 1700 core and 910 core voltage and 900 mem. So that's what I tried, but I went 1600 core, which was 100 core less. And I went 10 less on the actual core voltage to 900. I did hit that 27 like you said. We're actually over it. Like I said, it was 27.5. Now it's 27.49. But there's some stuff you got to see here. You got to recognize so you don't blow up and melt down your house or anything. So first we're going to look at our power. We're sitting at 245 watts. What did I do? Yeah, 245 is what I did my numbers on. So we're sitting at 245 here, bouncing up and up a little bit and down. Now we're going to go over some stuff here. Obviously, this is also why I recommend server power supplies for stuff. So as you know, we are coming out of here with one single PCI Express split into two. Now, for safest settings, you would not want to do this when it comes to Ravencoin. When you are switching coins off Ethereum and stuff, which does not use that much power, and swapping over to Ravencoin, people could run into problems, and this is one of them. I would recommend server power supply so you do have enough PCI Express cables. I don't want to pump this card up anymore in case I run into problems, because I am almost at pretty much the limit here. So right now I have all the power from this card coming into one connection here. Any connection, the weak spot is always in the pins. It's not usually the cable, unless you have Chinese knockoffs and they're actually pretending to be a lower gauge, like a bigger, thicker gauge, which is a lower number in here, so they put in more insulation. The wire is actually not as thick as it should be, but these are from Nergears. These are high quality, so the weak point is always in the pins if you have good quality cable. Now I would recommend having single each one in here, so you want its own 8-pin to its own strand. Now if you're using ATX power supplies, obviously you're going to need a couple of them. You're going to need a lot of PCI Express cables to come in here, because I would recommend individual, especially for core algorithm coins like Ravencoin. Now we're going to look at our numbers and see what's going on here. This is so far our most efficient settings. So as you said, or as I showed you there, 245 watts. We're subtracting our 19.5 watts out of the equation here. So we are our system. So we're at 225 watts the card is pulling. Now the riser is set for a maximum of 75, so we took that off. But Bitsby Trippin did a test, and his riser actually on a 5700 XT pulled more than 75 watts and would burn a Molex container. So yeah, his went over 75 watts, so it would burn a Molex. I'm just doing 75 as the maximum here. Again, pins is thing. So if we take off our 75 watts from our riser, we're sitting at 150.5 watts on our PCI Express cables right now. And like I said, They are rated for 150 a piece, unless you're using a server power supply where the 6 pins are all, there are more 12 volt rails through there. You can get a little more power supposedly in theory. But for an ATX, we are at our max limit right now, so I do not plan on going any higher on this card with this setup. I would have to swap all my PCI Express out, but we are sitting at, with, what did I say here, 27.5. We're at 27.52 now. We are at 0.182 mega hash per watt, which is our most efficient setting yet. So we're back at our card now. We went through our cables, we went through our power setup. Now we're going to look at the riser here. So like I said, it could go over 75 watts, even though the rating and they're all programmed and whatnot to not go over 75. BBT did have a watt meter through this. He has that special one, and it went over that 75 watt mark. So keep that in mind. That's why you do not use SATA connectors. You do not use Molex, because you don't know where those pins are from. It is hard to find information on them. So you do want to use PCI Express always on your riser, especially when you're going on to Ravencoin and core algorithms like Conflux and everything. So this is a big problem I foresee in the future. When Ethereum 2.0 comes out, people will swap their rigs over and look for the most amount of mega hash. And these are problems that you could run into. So always keep that in mind. You can't just swap over. It's a different algorithm, different coin, and a lot more power being used over Ethereum. So with that being said, we're going to try and pick it up a little bit more, see if we can get better, more efficient settings. We're going to need a little higher power draw here. So I did throw in another PCI Express here, and we did throw it in. So now we have 2 individual 8 pins going into this card. So we should be safe for more power now. So now we will pump this up some more and see if we can run more efficient. If you guys don't watch this video at all, I'm going to put in timestamps so you do watch just this section alone, because new miners and people that aren't too familiar with how the power draw and everything works, and if you're using SATA and whatever else, you got to watch this part. Like seriously, it is like it's a matter of your house still not lighting on fire. Just a quick update. I did mess up on the efficiency number there. I did it based on the 150 watts, but we still have to have that 75. So our card was pulling 225 watts when we took the system off. So we're only at 0.122 mega hash per watt. So now I'm going to be looking at, I did up the settings. As we saw, we changed our cables around, 1700 core, 910 VDD, and 910 on the memory. People do run this setting, so that's why I want to try this test out. And then we're going to look for the most efficient setting. But I just want to bring to light what you're actually pulling, because there are people out there that think mega hash is the best thing to get and not efficient. So I'm trying to show you efficiency is key. It's not the most amount of mega hash. So let's just keep an eye over that and try to remember that. Okay, so here are these settings. 1700 on the core, 910 core voltage, 910 memory. We're at 27.83 mega hash. And I just want to prove that people are running this. So here's a Reddit post. Where is it here? I'm using Team Red Miner with RX 5700 XT, settings at 1700 or 1600, which is what we're trying. Memory at 1800, which is 900 in Hive OS. But he's using this core at 950, so even more power than what we're using now. So let's just go take a look, because we are down to 910, like I said, on the voltage. We do have 10 extra memory, but that doesn't really matter. So people are running these settings, and they're just doing it wrong. Honestly, 100% wrong. So if that's you and you do see this video, I'm sorry, but a lot of people argue about trying to get the most amount of mega hash. So here we are at 253 watts. What did I do my numbers on? I did mine at, where is it? Can't even find it now. Where are we at? 254. So 253. Yeah, when we did it, we were at 254. So maybe I'll just redo them at 253. So I adjusted my numbers based on 253 watts at 27.8 mega hash. So we're at using 233.5 watts on the card, and that comes out to 0.119 mega hash per watt efficiency, which is just not that good. You want to run it as efficient as possible, especially with a higher core, with everything, especially when Ethereum 2.0 comes out. You don't want to be wasting any power at all. So, and that's also 158.5 watts, as you can see right here, is what's after the 75 watt on the riser. So this is what's coming out of your PCI Express cables. In theory, like I said, the riser could be pulling even more than that. the 75 watts here, but I just skipped that number and subtracted it, so just so you know. But yeah, so these are not efficient. I'm going to try to find some efficient numbers now, and then we'll compare the two to see what the actual power draw difference is between running these between like 6 and 8 card rigs. So I may have found our best setting here. We're pulling 26.23 mega hash, and we're using 1350 on the core. Our core voltage is 720. And our memory is 910, which is pretty much the same settings as we use for Ethereum. But I did get rid of my memory timings because they were interfering with like your VDD. Let's take a look at here actually, just kind of show you what I'm talking about. So our memory core voltage here and our memory controller voltage. So memory voltage, controller voltage. I got rid of them because they were interfering with the mega hash a bit. And now it looks like we're just running my Ethereum settings, 1350. We're sitting 26.23 mega hash, so we're going to take a look at our power draw, see exactly what's going on. But so far, this is looking like the best way to run this card. So 191.3 watts. It was bouncing between 190, 195, and up to 197 at times. So we're going to go with 191.5, I suppose. Here we are, 191.5 watts. Subtract our system of 19.5. We are at 172 watts, which gives us a hash to mega hash, or what? Oops. So 26.23 mega hash. So a hash per watt is 0.152 is our hashes per watt. So this is our most efficient setting so far. So that's looking good. So now let's compare this to what these other settings other people are using. Okay, so I did a comparison here just to kind of show what I mean, because in my past videos, even with the 5600 XT, people are like, that's not very much mega hash, it's not worth it, why would you run like that, run it a little harder, you know, all sorts of stuff like that. So I put some numbers into perspective, and maybe I can persuade some of you people why efficiency is a lot better than running straight mega hash. So here we have our 6 card rig running at our efficient settings here. So we have 191.5 watts, so we times it by 6 for 6 cards. We had our 19.5 system afterwards, and we were running 1168.5 watts for 157.3 mega hash. Now, if we were to run at the optimal, the 27.5 mega hash, like people like to run, and we saw people were running that, and these are the people that like to argue with it, where your mega hash is too low, you need more, or running Phoenix Miner, and it kind of uses power too and lies to you. But anyway, here we have 245 watts times 6 plus our 19.5. So we were getting 1489 watts for 165 mega hash. Now that works out to a 320.5 watt difference for only a 7.62 mega hash gain, which is efficiency of 0.023. Now look at that, and look at our power here, 191.5, 320. So we're using over a card's power. So I added up another card. So let's do a times 7 rig with these cards in here. So now we're using 1360 watts, which is still less than 6 cards here. And we're getting 183.61 mega hash, where now we're way over top of this. So look at running your cards efficiently is definitely way better than running inefficient, especially when Ethereum 2.0 is supposed to come out. All these coins are going to be flooded. Profitability is just going to dramatically drop. So Ravencoin is not like Ethereum. It does not have super high gas fees where you can just crank up the overclocks a little bit more and not have to worry, because you will get better results. You can run less efficient on Ethereum on high gas days and then just go back down to efficient settings. But if you're running Ravencoin, as you've seen, like, you got to rewire your cards separately. You need to run it because you don't want to melt anything. You're using a lot more core, especially with people using those high settings that are not efficient at all. Now this same strategy applies for Ethereum. You got to run efficient over non-efficient. The mega hash number does not matter if you're burning way too much power. You're just wasting power. You're wasting more coins to pay for your power. It's just not worth it. So anyway, I got that out of the way. I don't know how long this video is. It's probably getting pretty long by now, but now we got to check out this card on a riser and see what kind of if it changes out the power consumption at all, or if it changes our mega hash or not. As we wait for this card to spool up, we have it on a riser now. Now, always remember, especially when you're dealing with power, see if we can get in here a bit more. Not the greatest, but yeah, you want to make sure you're tight there, and you're going to want to be tight down here. because if this is not tight, you can burn it here, or if you put it in backwards, make sure you do put it in the proper way and everything is tight. I did add another PCI Express cable in to run to the riser separately. So you can see I have it powered right there with its own 6-pin, and again, because we are on Raven, these are each individual PCI Express plugs. Highly recommended. This is 100% the safest way to wire your rigs. Now I know you're running out of cables, you don't know what to do, you're using ATX power supplies, they're expensive to get even more, but I highly recommend server PSUs for crypto mining for that very reason. It'll save you headaches, they're cheaper than these, and I do have links in the description, so check that out. Parallelminer has all sorts of fun gadgets for crypto mining, so be sure to check those out. So let's take a look at our mega hash and power consumptions on a riser. So on our riser, we did get a peak here of 24.5 mega hash. And if we look at our power draw here, we're sitting at about 180 watts. So we've been noticing this with the 5600 XT as well, that when you move from your PCI Express slot to your actual riser on a card with Ravencoin anyway, I should test this out for Ethereum sometime, but we're actually using a little less power, but we're not getting the mega hash that we are. So maybe those boards and enough PCI Express lanes with all the times 16 slots and those other CPUs, they may be better for straight crypto mining rigs than all these other type of riser type of rigs. So the riser list may be better, but it's still up in the air. But I am noticing this with at least on Ravencoin. So let's take a look at our numbers and see what kind of efficiency we are on this riser, exact same settings. Here we are, guys. So 24.5 mega hash at 180 watts. We subtract everything, that's 160 watts after our system is gone. So we're doing 0.153 mega hash per watt. So that's still a little bit better than what we were pulling here. We're at 0.152 when we're on the riser, so 0.153. So we're slightly more efficient. You won't really notice that, so good stuff. So there's our riser. These are our optimal settings, I suppose. So 1350, 720 voltage on the core, 910 memory, and that was putting us at 26.23 mega hash in a times 16 slot. And on a riser, it was giving us 24.5 mega hash with slightly less power draw and a little bit more efficiency. So thanks for watching, guys. Hope you guys enjoyed this video, and I'll catch you on the next one. Rabid out.